Hello class, and welcome to our lesson on nuclear power, energy generation, and facility decommissioning. What you see on this title slide are the image of a model of an atom and a nuclear power plant. This image of the nuclear power plant is one that people will often see and assume that there's a great amount of pollution associated with nuclear energy. What you see emerging from the cooling towers is not smoke, it's actually steam, just basic water vapor. And nuclear energy is actually one of the cleanest forms of energy generation in terms of carbon release into the atmosphere. It is considered a clean energy source, but it is not a renewable energy source. That's an important differentiation to consider. Whereas solar and wind are both clean and renewable. Some objectives of this lesson include you should be able to explain the process by which nuclear power plants generate electricity and some of the obstacles while decommissioning a nuclear facility. First, let's go over some of the vocabulary. We're going to talk about physical components of a facility, including the reactor, the control rod, and the turbine. Some of the reaction components, including uranium, neutrons, nuclear fission, and energy. And then end of facility use terms. Decommission, and ISFSI. ISFSI is an acronym for Independent Spent Fuel Storage Installation. Introductory questions. When did nuclear power get its big start in the United States? That would be in 1958, was when the first U.S. facility was built for nuclear power generation. In 1975, Congress founded the U.S. Nuclear Regulatory Commission. And the U.S. generates 20% of its electricity with nuclear power plants, more than any other country quantity-wise, but not in percentage of use. And Illinois generates 56% of our energy from nuclear, a total of 98,000 gigawatts. That's more than any other state in the U.S., quantity-wise. Now, do our nuclear power plants use fission or fusion? Fission, and fission is the process by which a larger atom becomes smaller through the expulsion of a neutron. Fusion is what happens in the sun, where two smaller atoms fuse together to become bigger. You have two hydrogen atoms colliding to become a helium atom, and that releases energy in the process. And then how does nuclear fission produce electricity? The nuclear fission produces heat to boil water and produce pressurized steam. The steam spins a large turbine blade to drive magnetic generators to produce electricity. And what is the anticipated lifespan of a nuclear power plant? About 40 to 80 years. This regulatory commission will grant an initial license for a period of about 40 years, and then the facility can renew that license twice to give the facility about an 80-year lifespan. And here is a diagram of how a nuclear power plant generates the electricity. Here we have the containment structure. And in the containment structure, we have our control rods that we talked about. Now, control rods are made of a non-radioactive material that is able to absorb a lot of neutrons without undergoing the reaction. Here in the reactor, and here in this red box, is where we'll have our uranium. And as the uranium decays, it releases neutrons. As those neutrons are released, heat will be produced. These control rods can be inserted, and the further they go in, the more neutrons will be absorbed, so that will slow the reaction down. And here in the reactor, we have a fluid that then heats up. And as that fluid is pumped through, this is where the water is stored in the steam generator, and then that heat causes the water to turn into steam. And as the steam flows through the line, it'll spin this turbine here. As the turbine spins, there's magnets in here that will produce an electrical current, and that is then what goes into our grid and how we can power most of what we power in the state of Illinois. And then now we have all this really hot steam, and we'll have another sealed component of water here, and this will be the hot steam will come and heat up the water here, and then that goes in the cooling towers. Is that going back to that initial slide on the title screen where you saw all the steam coming out of the cooling towers. It'll then get mixed with a large reservoir, or it could be near a stream. So a lot of these facilities will be built near a body of water like a lake or a stream. And then as it cools, it will then come back in to this component where the steam will now condense back into liquid water and get pumped back through the system again. And so we're not really wasting this water here. These are three separate sealed components that then all interact with each other. This fluid in the purple that gets heated up by the nuclear reaction, then this water that gets generated into steam turns the turbines and condenses back into water, and then the cooling water that goes through the reservoir or the stream or the lake, etc. Here's some fast facts on nuclear energy. As I talked about, it's one of the cleaner forms, and nuclear fuel is extremely energy dense. One single uranium pellet, about 1 inch tall, can produce the same amount of energy as 17,000 cubic feet of natural gas, 120 gallons of oil, or 1 ton of coal. So we see here that it is a very useful in our communities. Now, nuclear power plant end of life. Why might a nuclear power plant cease operation? When the end of life could happen when the U.S. Nuclear Regulatory Commission no longer issues a license. It could be in the case of a natural disaster such as Fukushima, or war such as in the Ukraine, or human errors such as Zion or Chernobyl. Some of the challenges when shutting down and decommissioning a nuclear power station are logistical, storage and disposal of waste, cost of disposal, people losing their jobs, the effect it will have on the community, infrastructure, and the cost of electricity. Some background on Zion. Zion is located in Illinois, just a few miles south of the Wisconsin border on Lake Michigan. And on February 21st, 1997, a control room operator inserted the control rods too far during a shutdown of Reactor 1, and then withdrew the control rods without following procedures. What do you think happened next? The nuclear reactor slowed to a point of being non-critical, and it became too costly to restart the critical nuclear reaction. So ComEd, the licensor of the facility, then decided to decommission it. And what I want you to do now, I want you to watch this video I have linked here. You can also find it in our Google Classroom, and answer these questions while you are watching the video. And you can also find those on the Google Classroom as well. Go ahead and pause this video now and take some time to do that. Okay, welcome back. I hope you enjoyed the video. Here now is a satellite image of what the Zion facility looks like today. What you will see here, this is where the cooling towers used to be. One used to be here, and one used to be here. And this is Lake Michigan, this big blue part. Up north, at the north end of the map, it's 2.94 miles south of the Wisconsin border, and the southern end of this map borders the Illinois Beach State Park. And if you look down here, you'll see all of these little dots. This is the asphyxi. Those are each of those containers that contain the spent fuel rods that were shown in the video. And to prepare for the next class, I want you to read the article, How the 1970s U.S. Energy Crisis Drove Innovation, linked here, and come prepared to discuss this lesson, the article, and bring any questions or aha moments you have about energy production.